Okay, this is Dr. Williamson working on a titration problem. We're titrating the strong acid with a strong base. It says calculate the pH during the titration of 40 mils of 0.1 molar hydrochloric acid after adding each of the following volumes of 0.1 molar sodium hydroxide solution to a fresh 40 mil supply of the following, to a fresh 40 mil supply of the HCl. Part A, 0 mils of sodium hydroxide, B, 25 mils, C, 39.9 mils, and so on. So here we have our 40 mils of hydrochloric acid. It's actually water with chloride ion and hydronium ion floating around in there, right? We don't have HCl connected to each other. Here I have my burette of my 0.1 molar sodium hydroxide. What's actually floating around in there is water, sodium ion, and hydroxide ion. And here's our balanced chemical equation. Hydrochloric acid plus sodium hydroxide gives me sodium chloride and water. Hydrochloric acid is a strong acid, so it's a one-way arrow, plus sodium hydroxide is a strong base. Okay. In part A, to get the pH, it's minus the log of the hydronium ion concentration. And in part A, we want to know what the concentration is after we have added no sodium hydroxide, or what is the initial concentration. Well, the concentration of the hydrochloric acid, the very instant we put it in the water before it breaks apart, is 0.1 molar. And this will be 0, and this will be approximately 0. And then once it reacts with the water, because it's a strong acid, that'll be 0. This will be 0.1 molar. And this will be 0.1 molar. 0.1 molar. So then the pH will be minus the log of the hydronium ion concentration, which would be 1.0000. 4 sig figs, so I go to 4 decimal places. So that's part A, right? We did that. Let me erase this stuff. Part B, we need to know how much hydronium I have. Part B is I add 25 mils into here. I need to know how much hydronium is in here after I've added 25 mils of hydroxide. And I need to know what the volume is after I've added 25 mils of the hydroxide. Well, we need to figure that out. I've got this chart here that I kind of pre-made. Let me move this up over here. I need to know the starting amount of hydronium ion that's in there, because what's going to happen is the hydroxide is going to react with the hydronium and consume the hydronium that's in there. So for starters, I need to know what the volume is going to be after I've added 25 mils. After I've added 25 mils, the volume is going to be the initial 40 mils plus the 25 mils, which is going to be 65 mils. And then right now, you're going to be tempted to turn that into liters, because we're used to pH is minus log of the hydronium ion concentration, and that's going to be moles per liter. But I'm going to teach you guys something here that I want you to memorize for now. I'm not going to take the time to prove it. But 1 mole per liter is the same thing as 1 millimole per milliliter. So if I do things right, I can leave things in terms of milliliters, which I'm going to teach you guys here. So now you're responsible for knowing. What I'm going to do is I'm going to figure out how many millimoles of hydronium ion I have in here. And the way I'm going to do that is I'm going to go, okay, I have 40 milliliters of hydrochloric acid in here to start with. And if it's, since that's a strong acid, that means I have 40 milliliters of hydronium ion solution. And if it's 0.1 molar hydrochloric acid to start with, it's actually 0.1 molar hydronium ion. We just talked about that. And at 0.1 molar hydronium means 0.1 millimoles per milliliter. That cancels with that. And I end up with 4 millimoles of hydronium ion. Here I had a 40, put the decimal point in the wrong place. I have 4 millimoles. Okay, because it's 0.1 molar, not 1 molar. Right? I can do, and these are much more comfortable round numbers than doing something like 0.004 or something like that. Once I drip in 25 milliliters of sodium hydroxide, I can calculate how much hydroxide ion I've dripped in there. I'll calculate that now. I've dripped in 25 mils. And that is 0.1 molar or 0.1 molarity sodium hydroxide, which means 0.1 molar hydroxide, which is the same thing as 0.1 millimoles per milliliter. Milliliters cancel, and that gives me 2.5 millimoles of hydroxide ion. So I dripped in 2.5 millimoles of hydroxide ion. This 4 millimoles of hydronium is consumed by 2.5 millimoles of hydroxide. 4 minus 2.5 gives me 1.5. And I am left with 1.5 millimoles of hydronium ion. I can now calculate the pH after I've added 25 mils. The pH, oh, first off, let me do this. I need to calculate, I'll show you calculating the hydronium ion. I should have done that first. The hydronium ion concentration now will be 1.5 millimoles over 65 milliliters, which is the same thing as 1.5 moles per 65 liters. It ends up being the same thing as molarity. 1.5 divided by 65 gives me 0.02308 molarity. And when I take the minus log of that, the pH will end up being, hold on here, 1.5 divided by 65. I get, if I do this right, 1.6368. Okay. So let's part B. Part C, 39.9 milliliters. Well, it's a fresh batch of 40 mils. So the number of millimoles will be the same for starters, 4 millimoles of hydronium ion. But what will be the volume that I end up with? It'll be 40 milliliters to start with and 39.90 milliliters, 4, 5, 6, 7. That'll be 79.90 milliliters is total volume. What is the amount of hydroxide ion that I've dripped in? That'll be 39.9 milliliters times 0.1000 millimoles of hydroxide ion per milliliter, because it's 0.1 molarity. That means 0.1 moles per liter or 0.1 millimoles per milliliter. When I do that, that's going to give me 3.990. So 4 minus 3.990 gives me 0.01120. Okay. And then the hydronium ion concentration will be 0.010 millimoles over 79.90 milliliters divided by 79.9. I get a small number, of course. I get 0.00013. And the pH, when I take the minus log of that, it's going to be 3.90 or so, 3.9, 3.903, right around there. Okay. So there's that. That's part C. Part B, 40 mils. Gonna do a little bit of thinking on this one, actually. Okay. 40 mils. So erase this, erase that. Okay. So if I add 40 mils, I started with 40 mils, a fresh batch of 40 mils. So when I'm done, I got 80 mils. How much hydroxide did I drip in? 40 mils. And it is 0.1 molarity hydroxide, which is millimoles per milliliter of hydroxide. And that's going to be 4.000. And so when I'm done, I end up with nothing there. I have exactly used up all the hydroxide with all, used up all the hydrochloric acid with an exact amount of the hydroxide. So what's going on? What do I have left now? So I started with, let's look at it this way. Let me kind of do it like this. Choose different color. I had, for starters, 4 millimoles of that. And then I added 4 millimoles of this. So when I'm done, I've got none of this and I've got none of that. What am I left with? I'm left with salt in water. So now in here, I have a beaker of water with sodium ions and chloride ions. Sodium ions and chloride ions are both spectator ions. So they're not doing anything. So what's the pH of this pure water solution? The pH will be 7. Why is the pH 7? You need to know this for the test. The pH will be 7 because all that's going on in here is water reacting with water in equilibrium to make hydronium ion plus hydroxide ion. And at 25 degrees Celsius, the hydronium ion concentration is 1.0 times 10 to the minus 7 molarity. And when I take the minus log of 1.0 times 10 to the minus 7 molarity, that gives me a pH of 7. So don't just say, well, it's neutral and the pH of neutral water, of pure water, when it's neutral is 7. You got to tell me why. Well, because in pure water, the hydronium ion, the measured concentration is 1.0 times 10 to the minus 7. Take the minus log of that, you get a pH of 7. Okay. Next question. What happens when I add right? Last one. This is a whole test in itself, right? What happens when I add 50 mils? We did this one. Happens when I add 50 mils. The volume will be 50, right? So now I've got 90 mils. How much hydroxide ion did I add? 50 mils times 0.1000. That's millimoles per milliliter of hydroxide ion. That's going to end up being 5 millimoles. So guess what happens, right? This ends up being 0, and this ends up being 1. So now, this is not -1, guys. It's not like 4 minus 5 gives me -1 millimoles of hydronium ion. You can't have a negative millimoles. Okay. Once I run out, I run out. So now I have 1 millimole. So what's that going to be concentration of? I'm going to have here my hydroxide ion concentration will be 1 millimole over 90 milliliters. I'm going to go 1 divided by 90. Make sure I did that right. 1 divided by 90. And I'm going to get 0.01111 millimoles per milliliter, which is 0.01111 molarity. POH will be minus log of that, gives me a 1.9542. So then pH will be 14 minus that, gives me 12.05. Okay, guys. Anyway, hope that was fun. I had a good time. And wait till we do the ones with strong base and weak acid. Then we do this kind of stuff, plus we throw in the Henderson-Hasselbalch equation. All right. Talk to you guys later.